On a clear night, the sky feels peaceful, still, unchanging. The stars seem locked into place, as if they've always been there and always will be. But that feeling is an illusion. Every single star you can see is moving through space at incredible speed. Some are drifting away from us, others are racing sideways across the galaxy. A few are quietly changing direction altogether, pulled by gravity we can't see. The night sky is not a photograph, it's a slow-motion film. And the shapes we call constellations are temporary frames in that film, visible only because we happen to be alive at this exact moment in cosmic time. In this video, we're not talking about myths or legends, we're talking about real space physics. Using modern astronomy, precise star mapping, and long-term simulations, scientists can already see the future of the night sky. And what they see is both beautiful and heartbreaking. Because many of the constellations we recognize today are slowly falling apart. This is the story of constellations that will disappear forever. Welcome to Galasky. The first thing to understand is this. A constellation is not a real structure in space. It's not a group of stars bound together by gravity. It's not a physical shape floating in the universe. A constellation is a projection. When we look up, we're seeing stars scattered across vast three-dimensional space, collapsed into a flat image by distance. Some stars that appear side by side are separated by hundreds of light years. Imagine standing in a forest. Two trees may line up perfectly from your point of view, but one could be 10 feet away and the other a mile behind it. Move just a little and the alignment breaks. That's exactly what constellations are, alignments created by perspective, and perspective changes. There's another reason constellations feel so real. The human brain is designed to find patterns, even when none actually exist. It's a survival trait. Recognizing shapes helped our ancestors spot animals in tall grass, faces in shadows, and danger in the dark. So when we look at the sky, our minds automatically connect dots. We draw lines between stars. We imagine figures, animals, and tools. We turn randomness into meaning. The universe doesn't create constellations. We do. And that's part of what makes them powerful. They exist at the intersection of physics and perception, where cold cosmic motion meets human imagination. Stars are not fixed. They orbit the center of the Milky Way at speeds that can exceed 500,000 miles per hour. Each star follows its own path, influenced by gravity, past encounters, and the galaxy's structure. This motion is called proper motion, the apparent movement of stars across the sky over time. For most of human history, this motion was invisible. Our lifespans are too short, the changes are too slow. But today, we can measure them. The European Space Agency's Gaia spacecraft has mapped the positions and motions of over 1 billion stars with astonishing precision. Using this data, astronomers can rewind and fast-forward the sky like a time machine. And when they do, constellations don't survive. They stretch, they twist, they dissolve. It's difficult to grasp just how fast stars are moving because we don't feel it. There's no wind, no vibration, no sense of speed. From Earth, everything feels calm, but calm does not mean still. The sun carries the entire solar system through space at hundreds of thousands of miles per hour, yet life continues as if nothing is happening at all. That disconnect between motion and sensation is why constellations feel permanent. When we imagine space, we picture emptiness, a silent black void with stars pinned in place like decorations. But space is not empty, and it is not still. We are inside a moving ocean of stars. The Milky Way is a rotating disk, thick with gas, dust, and hundreds of billions of suns. Everything inside it is in motion, not randomly, but in vast, graceful arcs shaped by gravity over billions of years. Our sun is one of those stars. Right now, as you watch this video, the sun is carrying Earth through space at extraordinary speed, not just around the sun, but around the galaxy itself. Every night sky you have ever seen was viewed from a moving platform. That means the constellations you recognize are being drawn on a shifting surface. The canvas itself is sliding beneath your feet. We just don't notice because the universe moves on timescales far longer than a human life.
Let's talk about depth. When you look at a constellation, you're not seeing a flat drawing. You're seeing stars at wildly different distances, layered on top of each other. Some stars are relatively close, within 50 light years. Others are hundreds or thousands of light years away. This matters because distance affects motion. Nearby stars appear to move faster across the sky, while distant stars barely shift at all. Over time, this difference tears constellations apart. Astronomers use three-dimensional models to show this effect. When constellations are rotated in depth, their familiar shapes collapse instantly. What looks beautiful from Earth often looks like chaos from any other angle. Constellations only exist from here, from now. Imagine if you could pause time and then slowly let it move forward. Not seconds, not years, but thousands of years at a time. You would see stars drifting apart like glowing embers from a fire, shapes stretching, bending, losing their symmetry. Constellations wouldn't disappear all at once. They would unravel, so slowly that no one living through it would ever notice. Change in the universe is almost never sudden. It's patient. This has already happened before. Thousands of years ago, ancient humans saw constellations that no longer exist today. Their skies were different. Written records from early civilizations describe star groupings that don't match any modern sky maps. The stars are still there, but the shapes are gone. Not because the ancients were wrong, but because the sky changed. We are borrowing this version of the universe for a moment. Orion is one of the most photographed regions of the night sky. But Orion is unstable. Its stars are not a family. They're not moving together. They just happen to line up, temporarily. Betelgeuse, a red supergiant nearing the end of its life, is drifting in a different direction than Rigel, a massive blue star burning hot and fast. The three belt stars, often assumed to be aligned in space, are spread across hundreds of light years. Using Gaia data, astronomers have simulated Orion's future. In 10,000 years, the shape begins to stretch. In 50,000 years, the belt bends. In 100,000 years, Orion is unrecognizable. He doesn't explode. He doesn't fade dramatically. He simply comes apart, quietly. There's something quietly unsettling about knowing Orion won't last. Not because it's useful, not because it's important for science, but because it feels familiar. Across cultures and across centuries, people recognized Orion without sharing language, borders, or written stories. Hunters, warriors, giants, guardians. Different names, the same shape. That kind of agreement across human history is rare. And knowing that this shared image will vanish feels like losing a reference point across time. A silent connection between people who never knew each other but looked up at the same sky. What makes Orion powerful is not how long it lasts, it's that it exists at all. Those stars were never meant to form a figure. They were born in different regions of the galaxy, at different times, under different conditions. They don't share gravity. They don't share direction. They don't even know they belong together. If Earth were positioned just a few light years away, Orion would never exist. The hunter only appears because of where we are and when we are. That makes Orion less permanent and more miraculous. It is not a monument carved into the universe. It is a coincidence we get to witness. For many people, Orion is the first constellation they ever truly notice. It rises in winter skies. It stands bright and unmistakable. It feels like the universe pointing something out on purpose. When you learn that Orion will dissolve, the loss feels subtle but real. Not because the stars will disappear, but because this version of the sky will never return. The Orion you see tonight is a one-time arrangement in the history of the galaxy, and once it's gone, no future civilization will ever see it the same way again. And Orion is not alone. Other constellations we trust, other shapes we assume will always be there, are already beginning the same quiet journey.
The Big Dipper feels permanent, familiar, reliable. For many people in the Northern Hemisphere, it's the first constellation they ever learned to recognize. It feels like an anchor in the sky, something you can always find no matter where you are or how lost you feel. But the Big Dipper is a coincidence. 5 of its stars were born together and move through space as a loose traveling group. They share a common origin, drifting through the Milky Way like siblings who grew up in the same place. The other 2 do not. They were born elsewhere. They are moving in different directions. They just happen to be passing through the same line of sight right now. From Earth, they look united. In reality, they are strangers. Over time, that difference becomes impossible to hide. The stars that belong together continue on one path. The others slowly peel away. The bowl stretches wider, the handle bends out of alignment. The clean, familiar shape begins to soften and distort. Not suddenly, but enough that future observers will struggle to recognize it. In about 100,000 years, the Big Dipper no longer points clearly to the North Star. For thousands of years, humans used that alignment to navigate, to cross oceans, map land, and find direction when nothing else was reliable. When that alignment fades, navigation changes. The sky loses a landmark. Not because the stars are gone, but because the relationship between them no longer exists. There's a reason people feel deeply attached to certain constellations. They're not just patterns, they're memories. Camping trips where the sky felt impossibly large. Power outages where stars replaced screens. Late-night conversations that drifted into silence as everyone looked up. For many people, the Big Dipper was the first time the universe felt real, not as an idea, but as a presence. When a constellation disappears, those memories don't vanish, but the visual anchor that held them does. It's not nostalgia for stars, it's nostalgia for who we were when we looked up, when the world felt quieter, when direction felt clearer, and when the sky seemed like something we could count on.
The southern sky is shifting just as dramatically. From the southern hemisphere, the night sky tells a slightly different story, one that feels just as stable, just as familiar, and just as temporary. Constellations like Crux, the Southern Cross, have guided travelers, sailors, and entire cultures for centuries. It appears fixed, compact, and dependable, a symbol printed on flags, carved into monuments, and passed down through generations. But Crux is not immune to change. Its stars are slowly drifting, each following its own path through the Milky Way. Over tens of thousands of years, the clean cross shape begins to stretch and skew. The symmetry that made it recognizable gradually softens, not because anything dramatic happens, but because time never stops. At the same time, Earth itself is changing how it points to the sky. Earth's axis doesn't stay perfectly still. It slowly wobbles, a motion called axial precession, completing one full cycle roughly every 26,000 years. This wobble changes which stars we see. Stars that were once permanent fixtures slowly sink below the horizon. Others, unseen for thousands of years, rise into view. Entire constellations drift in and out of human experience, not because the stars move closer or farther, but because we do. The night sky you see is shaped by latitude, era, and motion. It depends on where you stand on Earth and when you exist in history. There is no single permanent sky, only versions. It's tempting to think of the sky as something we own. We named it, mapped it, organized it. We drew borders between stars and decided which patterns mattered. We treated the heavens as a fixed backdrop, something eternal, something reliable. But the sky doesn't belong to us. We are temporary observers, living brief lives inside a vast, moving system that existed long before humanity and will continue long after we're gone. The stars don't rearrange themselves for us. They don't preserve familiar shapes. They don't pause to remain recognizable. Constellations aren't being taken away. They're simply moving on. And in that motion, there's something quietly humbling, because it reminds us that the universe is not centered on memory, tradition, or comfort. It's centered on motion, and we are just passing through one beautiful alignment of it.
Astronomers don't have to guess what the future night sky will look like. Using precise measurements from missions like Gaia, scientists can calculate the exact paths of stars thousands of years into the future. When those movements are projected forward, the sky begins to change in subtle but unmistakable ways. At first, the differences are almost invisible. Familiar stars drift just a fraction of a degree, lines stretch slightly, angles soften. To the human eye, the sky still looks the same. But as the simulation continues, the changes compound. Constellations lose their balance, symmetry breaks. Shapes that once felt intentional begin to look accidental. The patterns our ancestors memorized no longer hold together. The Big Dipper slowly opens, its bowl widening as its stars move along different paths. The handle bends into longates, no longer forming a clean arc. What once pointed reliably toward Polaris becomes an uncertain guide. And Polaris itself doesn't stay where it is. Earth's axis continues its slow wobble, a cycle known as axial precession. Over thousands of years, the role of North Star passes from one star to another. In the future, Polaris drifts away from the center of the sky, replaced by stars that today feel insignificant. Navigation changes, orientation changes, the sky loses its familiar anchor. In the southern hemisphere, the transformation is just as dramatic. The Southern Cross, a symbol used for navigation, culture, and identity, stretches and tilts as its stars drift apart. Its clean, recognizable shape softens into something less precise, less iconic. Some constellations slowly sink below the horizon, never to rise again for observers at certain latitudes. Others emerge for the first time, stars that were once hidden becoming part of everyday night skies. The sky is not universal. It depends on where you stand and when you exist. Fast forward far enough, and the sky becomes unfamiliar. There is no Orion, no Big Dipper, no Southern Cross.
Instead, there are stars without names, forming patterns that mean nothing to us, but everything to the people who will live under them. Those future observers will draw their own lines, they'll tell their own stories, they'll believe their constellations are permanent, just as we once did. And somewhere in their science textbooks, our constellations may appear as diagrams, labeled, dated, and marked as temporary arrangements that existed long ago. A snapshot of a sky that no longer exists. What makes this realization powerful is not loss, but timing. You are alive during a rare alignment of stars. You are seeing patterns that only exist for a brief window in cosmic history. These stars have been moving for millions of years. They will continue moving for millions more. But right now, from this small planet, at this precise moment, they form shapes that humans recognize, remember, and emotionally connect with. The night sky you see is not ancient. It is not eternal. It is a moment, and moments are what give meaning to the universe.
Constellations don't require telescopes. They don't require equations. They meet us where we are. You don't need training to understand them. You don't need permission. You just need to look up. Knowing they're temporary doesn't weaken them. It makes them precious. Because when something lasts forever, we stop noticing it. But when something exists for only a moment, even a long moment, we pay attention. You are witnessing a rare alignment. That moment is now. For most of human history, the night sky was the same for everyone. No matter who you were or where you lived, you shared something in common with every human who came before you: the stars. People crossed oceans guided by them. Farmers measured seasons by them. Children fell asleep under them. The sky didn't belong to scientists. It belonged to everyone. And constellations were how humans made sense of that vastness, not by controlling it, but by relating to it. They turned distance into familiarity. When we learn that constellations will change, something shifts in how we see the night. The sky stops feeling like a backdrop. It becomes a living system, slow, patient, and in motion. The stars aren't posing for us. They're passing through, and so are we. That realization doesn't make the universe feel colder. It makes it more honest. Knowing the sky will change doesn't make it less beautiful. It makes it more valuable. Because permanence is common, but moments are rare. The constellations you recognize are not guaranteed. They exist because of timing, because of where Earth is, because of where you are, because of now. One day, they will be gone. But tonight, they are still here. And that is enough.
The universe doesn't rush. Stars move patiently. Galaxies evolve slowly. But within that vastness, there are brief arrangements of beauty. Constellations are one of them. They are not permanent. They are not guaranteed. They are a gift of timing. If videos like this help you feel connected to the universe, not just as science, but as experience, then this is exactly what Galasky exists for. Here, we don't just explain space, we feel it, because every night sky is a moment in time.